In this video, we come to the second in our examples of free response questions involving Euler's method. Now this one also involves slope fields. So we consider the differential equation dy dx is equal to 2y minus 4x. First, the slope field for the given differential equation is provided. Sketch the solution curve that passes through the point 0, 1, and sketch the solution curve that passes through the point 0, negative 1. Well, for 0, 1, we have basically a linear function there, which appears to be the line y equals x plus 1. Now for the point 0, negative 1, you can see that it's not going to be the same. It's kind of falling off to negative infinity at that point. And so it probably looks something like that. Again, it doesn't have to be exact, but we're following the direction curve provided there. Alright, so that's it for part A. For part B, let f be the function that satisfies the given differential equation with initial condition f of 0 is equal to 1, using Euler's method, starting at x equals 0 with a step size of 0.1, or use Euler's method to approximate f of 0.2, show the work that leads to your answer. Again, with Euler's method, we have the initial x and y values, and in this case, that's 0 and 1. We have our delta x, which is 0.1, and we have our y prime, which is 2y minus 4x. So 2y is 2, 4 times 0 is 0, so that means y prime is 2. And the delta y will be y prime times delta x, so 2 times 0.1 will give 0.2. And since I'm running out of room there, I'll just put my x plus delta x under x. That'll be my new x. So x plus delta x will be 0.1, and y plus delta y will be 1.2. And these will be the new values that we'll use to calculate y prime and delta y. Delta x remains at 0.1. Delta y will be 2y, so 2 times 1.2 will be 2.4, minus 4 times x, or 0.4. So 2.4 minus 0.4 will be 2 again. And the delta y will be 0.1 times 0.2, which is also 0.2. Now this makes sense because at 0, 1, the function is growing in a linear fashion, and that's exactly what we're seeing here. Every time you go up by 0.1, the y value is going up by 0.2. And so the new x value will be 0.2, or the old x plus the delta x, and the new y will be the old y plus the delta y, which would be 1.4. And so that would be our approximation of 0.2. It would be 1.4. Now in part B, it asks us to find the value of b for which y equals 2x plus b is a solution to the given differential equation and justify the answer. So for part C, if y equals 2x plus b is a solution of the given differential equation, then we can substitute 2x plus b for y in the differential equation. And when we do that and simplify, we get that dy dx is simply 2b. Now then, the derivative of y equals 2x plus b is 2. So it means at that point, dy dx has to equal 2 also. And since 2b equals 2, then b equals 1. So we were given an equation y equals 2x plus b that is a solution of the differential equation. That means that we can substitute that solution, that equation, for y, which we did. And if 2x plus b is a solution, then its derivative, which is 2, has to be equal to the derivative at that point. And so we equate those two together and get b is equal to 1. Now we'll continue with part D in the next video of this series.